Hello, everyone. This is Giacomo Beccari speaking, and on behalf of the ISO Office for Science, I would like to welcome you all to the third day of the ASTRO 2022 conference, the present and future of astronomy. This is today, the topic of today is assessment and metrics, and the program, as you can see online, the program foresee 2 invited speakers plus 3 talks, 3 contributed talks. There will be a part 1 between now and roughly to 3:30, and then we will make a break of some minutes of break, and then we start again with part 2, starting at 4, and then we conclude with 1 hour discussion. Please stay with us, as the discussion has been, we saw in the last days, in the first 2 days, that there is a very lively discussion and interaction with our speakers, and we are really looking forward to, of course, listen to all the talk, but also to engage in this discussion with our participants. Let me give you some general, very quickly, details related to how to participate. If you are on Zoom, by default at the beginning, your camera and microphone are off. Then if you want to make a question, please, you can either write the question on the chat, or if you like, you can also raise your hand, and then the chairman will say the name of the person, and then you will be allowed to make yourself the question. And if you want, also turn on the cameras and introduce yourself to the speakers. That's of course very, very nice if you can do that. If you are on YouTube, you can make the question using the live chat, and then we will pass it to the chair, Sean. Then, as I said, there is a break between part 1 and part 2. So on YouTube, you will be disconnected to the current live event, and then there will be a new live event appearing as a part 2 at 4, when the next talk, the first talk of the session 2 will start. So connect back to the main page of a ESO Duolog channel, and you will see the live event popping up, and then you can join again, and then the event starts again. Finally, if you want to make questions or comment but remain anonymous, you can use the online form available on our ASTRO 2020 pages. This is a link available here. You can go and write a question, then we will receive it in real time and pass it to the chair of the session. And the event is live streaming on YouTube, so for people on Zoom, please be aware this is the case. So if you are uncomfortable with being streamed on YouTube, please leave we ask you to please leave the meeting, but you can still, of course, follow the meeting entirely on YouTube. Also, the same formularium, the same online form can be used also by the people, of course, on Zoom. If you want to make your question anonymously, you can use the form online. Finally, an aspect that is very important to us is the code of conduct. Of course, especially during the discussion, we acknowledge it's not easy to have a discussion online, but we really trust that we want to create at ESO. We trust in the code of conduct that we want to create an atmosphere that is comfortable, and all opinions are welcome and should be spoken, but everyone should be please professionally show tolerance and respect for the views of each other. There are 2 contact points. It's myself, Giacomo Beccari, this is my email, and Anna Miotello. All participants are free to report any violation of the guidelines to myself or Anna, and this will be treated, of course, in full confidence. And with that, I think I can conclude, and I can thank you all. I wish you to enjoy the event, of course, and I pass the word to Sean. Hi, Sean. Nice. Thank you for being with us. Sean is, just to briefly introduce, Sean completed a PhD in 2016 in biology, so in the metabolism of immune cells, right? Then afterwards worked in the rectorate of the University of Luxembourg, and responsible for internal communication between management and research community. And this is great for us, and that's of course a lot of training and expertise that is going to be a big help to us today. And since 2017 is a program manager of the Luxembourg National Research Fund, and responsible for biomedical sciences, strategic funding programs, and research culture. So this is all great and very, very, very fascinating curriculum. Thank you very much. Congratulations. It's a pleasure to meet you, and thank you for your help during the whole event. Sean,
thank you very much, Giacomo, for those kind words. And hopefully those skills will come into play today. And as Giacomo has already introduced, we have assessment and metrics as the topic for today, and a very great group of speakers to speak about all aspects of this. And so without further ado, let's jump right into the first talk. So Noemi, please turn on your video and share your slides. Our first speaker today is Noemi Aubert-Bon. She's a postdoctoral researcher at Hasselt University in Belgium, and as well as the Amsterdam University Medical Center. Noemi has recently completed her PhD at Hasselt, where she was exploring different stakeholder perspectives of the impact on current research assessments and definitions of success in science, and what impact these have on research practices and research integrity. And she's going to talk today about changing cultures. So please, the floor is yours. You have 30 minutes.
Thank you so much, Sean, and thank you for inviting me to talk in this conference. I had the chance to be able to follow some of the presentations in the past few days, not all of them because of schedule issues, but what I could see, especially in yesterday evening, I think was very rich, and I'm looking forward for the discussion today. So thank you very much. So my name is Noemi, as Sean mentioned, and I am a postdoctoral researcher. But one thing that might be interesting to mention is that I am doing research on research assessment and research integrity because I was a bit mad at how the system was, and this is what decided me to change. So I think from what I talk, many of you as young researchers who are not necessarily experts on integrity and on research assessments will probably relate with what I'm saying. Or at least be able to understand what I'm saying much better than I would understand if you were talking about your own expertise to me, I'm pretty sure. So today I want to give you a short story of success, and I would like to introduce success, give you a broad idea of what success means in science. And to do that, I will focus on findings from different research projects that I've been doing. So the first two projects that I will talk about are projects from my PhD studies. So the first one is a series of focus groups and interviews that I conducted with diverse stakeholders. And the second one is a small survey with researchers. And I will also talk about a project that I'm currently working on as a postdoc, which is part of a massive survey in European Commission Horizon 2020 project called SOPS for Array. So I will use these three findings from these three projects to talk about three main topics. So the first topic I want to look at is at perspectives of success in science. The second one is perspectives of indicators that are used in research assessment. And the third one is perspective of the reform of research assessments. So first, perspective of success in science. All right, so to look at this, I use findings from focus groups and interviews that I've conducted as part of my PhD research. So I conducted 56 interviews and focus group with 56 stakeholders. And by stakeholders, I mean researchers, so research students and researchers, but I also interviewed and conducted focus group with different research actors to have an overview of what do we really mean with success in science? What is success in science and how do we perceive it? So what did I find? This is qualitative work, so it's I will use a lot of words, and I'm really happy to answer more questions afterwards to give you some quotes and to give you some details later. So three main findings that I want to talk about when we talk about success in science. The first thing is that research success and career success are often incompatible with one another. So I found that the way people describe successes for their career or successes for research was very different. So on the one hand, to be successful in their career, researchers are taught to need to publish a lot, to do a lot of work, to focus on quantity. They should create exceptional findings. They should focus on having a wonderful individual CV with individual achievement. They should be competitive. They should conduct research where they're pretty sure they're going to get positive results. And if they have a sensational topic, that's jackpot, and they're sure that their career is going to boom. So this is what people were sort of giving me as a caricature of a very successful researcher. But when they were describing success for research, and they always made the distinction, then they would say, well, if we want to make research better, then we need high quality science. We need findings that are reproducible, not just exceptional. We need collaboration, we need to share data, to share our findings. We also need to do research on innovative fields that have a high risk of yielding absolutely no positive results. And finally, for research to be successful, the findings should be transparent, honest, and modest. So we can see that we have really an incompatibility between the two, and sometimes it can even lead to a competition between career success and research success. Another thing that I found was that career success is almost exclusively focused on output, and it ignores most of the processes involved in research. So here I put just a bunch of things that you do as a researcher that you have to do throughout the life cycle of a project. But when we really look at what is investigated, what is used in research assessment, then we have something more like this. So we look at the publications, sometimes maybe the patent, if you're in that kind of field, and past funding acquisition. But that's really it. And all the rest is completely ignored from research assessments. And finally, the third finding that I want to talk about in terms of success in science is that we know we have these problems, and people agree that we have a problem, but they said that it was very difficult to change and to address these issues. So part of my interview guide and my focus group guide was to ask people, okay, so you've told me about all these problems, who's responsible for the problem and who's responsible for solving the problem? And I'm a researcher, so myself, my view would have been, okay, so probably the big actors, the one with the money, they're responsible for changing things. And I did find that, but because I had interviews and focus group with all these different actors, I found a pretty complex picture where it's not just the big actors that are responsible, but there's also some responsibilities on other actors, including on researchers, because researchers are in the end the ones who sit on assessment committees. They're the ones who create the culture of research, and I'll get back to that later. But they do have a role in these problems. And so what happens now is that nobody feels able to change the system. And there's a lot of, I would say, feeling of hopelessness, like this is how it is. There's nothing that we can do. So this is, these are some quotes from my participants that I thought were really revealing when I am quite optimistic and I really want things to change, but there's still a feeling that it cannot really change. And linked to that, so it's very difficult to change and address the problems, but also the career structures that we have at the moment may strengthen the problem. The participants that I had in the interviews and the focus group often referred to a funnel structure in academia. And this is referring to the fact that there's a lot of PhD students and a lot of people entering academia, but only a few of them will be able to have a tenured position some years in the future. In Belgium, where I was doing my research, it was about 1 out of 10. So that's very little. And okay, that can seem not too problematic, but there's a few issues that are very important about this funnel structure. So the first one is that it leads to a lot of competition. It leads to competition with young researchers, between young researchers, and that leads to isolation, stress, mental health risks. And there's more and more research showing that young researchers are really at high risk for mental health issues. And when you reach postdoc level, then it also leads to insecurity in your career. Are you going to be able to keep your job? People go from contracts of 6 months to contracts of 6 months sometimes, and they are at an age where they start having a family, start buying a house. So this was something that the postdocs that I interviewed were really worried about. Another problem from this funnel structure is that it blocks diversity. And for those of you who were able to attend the talks and the discussion from yesterday, I think this was very clear that there are efforts happening, but still many of my participants would mention this profile of the typical PI, and the typical PI being the one profile that can make it to become an academic, a tenured professor in academia. And apparently there's not so much diversity into that. So there's gender diversity, but this was more about the skills diversity and the type of person, the type of achievements that you want to do. And then also because there's so many people who have to leave academia, well, we have to consider that for each professor, there's 9 students that have to leave academia. And some of them are quite happy to leave, and they entered in academia because they wanted to work in the industry. They're really happy. They found a good job in the industry. But for some other students, well, they leave, but they wanted to continue in academia, and they leave without wanting to leave. And I don't know if you noticed, but parts of my participants included people who left academia, and I wanted to see their perspectives of success, their perspective of science. And what I figured out is that when they leave academia, a lot of them felt like they were a failure. So they felt like them leaving academia was because they were a failure. They were not a real scientist. They were an idiot. They gave up. And that feeling is quite problematic, because in the end, when you think that 9 out of 10 people will have to leave the system, well, it's not them who are the problem, it's the system. And the last point I want to bring up about this funnel structure is that, and then it links back to the fact that it's difficult to change, is that because of this funnel structure, well, then problems solidify and are anchored in the culture of research. And this is something that I think Tiago mentioned during the discussion yesterday. So the ones who succeed in science are also the ones who will assess others, and they're the ones who will teach early career researchers how to survive in science. So in the end, it's not because they're bad people, it's not because they want the system to stay how it is, but it's because this is what they learned, and it's very difficult to change how you learned to be successful and to teach others to be successful in different ways. So because of that, we have this sort of looping system where there's not much change happening. All right, so the second topic I want to talk about is the perspective of the indicators used in career advancements. For this, I will use findings from a small survey that I conducted as part of my PhD. And it was a survey during which I had 18 statements of actions that could be considered indicators for success. And for each of these, I asked the respondents, how important is that in advancing your career? How important is it in advancing science? And how important is it to your personal satisfaction? I will not look at the last part, but you're welcome to look at the paper if you want to know more about that. So it was a small survey. I had 126 respondents, mostly Flemish, but from all fields of research. And these are the results. I will not go in depth because they're a bit too complex, but I just want to show a few trends. So first, there were indicators that were thought to be most important in advancing science, but not as important in advancing careers. And these indicators were tended to be related to openness, transparency, quality, and innovation. So no surprise here. On the other end of the spectrum, there were indicators that were thought important for advancing science, but less important in advancing careers. And these tended to be related to luck, prestige, status, competition. So basically what we have is that the indicators that are seen as most important to advancing science are not always aligned with those seen as most important in careers, in researchers' careers. And then also on the indicators, I wanted to bring up some results from a large survey with European researchers from the project that I'm currently working on. So this is a survey from the SOPS4RI European Commission project. I am not the coordinator of the survey. It's a survey coordinated by the University of Essex, by Nick Allum and Abigail Reid. And I really thank them for lending me their data. And I just want to mention this is preliminary data, so please do not distribute. It could change. So if you could avoid taking screenshots just for this section, I know it will be online, but the results might change after we clean the data. So I just want to give a word of warning here. So this was a very big survey with about 50,000 researchers involved. And we asked two questions about research assessments. So the first question we asked was, when a researcher's performance is being evaluated by an employer or a potential employer, how important do you think it is to include each of the following activities in making an assessment of their performance? And then we have all these different activities, including publication metrics, for example. And these are the results. And again, I will just show you some trends. So the first trend that I noticed is that there are some indicators that are mostly seen as fairly important, but not so often seen as very important. And these, quite interestingly, include publication metrics. So these were the mildest indicators, the indicators that people thought were not so important, and publication metrics are part of these. Then there was outreach and communication of research to public audiences. That was seen as very important by a few more people. And finally, there were some indicators that were seen as very important by the majority of respondents. And these were teaching, leadership, supervisory responsibilities, peer review, and collegiality. And what's really interesting about this is that all of these are not research outputs. These are processes. These are the things that you do as a researcher, but that do not necessarily lead you to publish, lead you to have research results. And at the moment, well, these are mostly, well, very rarely captured in research assessment and very rarely captured in metrics and in measurable indicators. And then that leads me to the last point that I want to raise, which is what are the perspectives of the reform of research assessments? So I'm going back to this same survey, still preliminary data. So we had a second question in the survey, which it was a series of scenarios. And then we asked, how do you agree with this? Do you think this is a good idea? Do you think this is a bad idea? And this was given to a subset of the respondents. So 4,700 researchers responded to that question, more or less. And the question, well, the scenario was, organizations should not assess researchers using metrics that emphasize quantity or journal level impact, such as publication counts, H-index, and journal impact factors. And I'm pretty sure that Stephen, who will talk about DORA later, kind of see a familiarity in that statement. So we asked respondents, do you think this is a good idea? This is what we found. So this is all the respondents. Some on the red side think it's not a very good idea. Some on the green side think it's a good idea. And it's quite reassuring because we can say that over half, so 58%, think that it's a good idea. But then I wanted to look a bit more in depth. Who says that? So I looked at the seniority levels, and I cut the results between seniority levels. And you can see that, let's say, who thinks it's a bad idea? Well, there's twice as many later career researchers who think it's a bad idea than early career researchers. There's also the retired researchers are mostly neutral on this question. I don't know why. I don't know how to interpret this. And what I found very interesting is that almost a quarter of early career researchers think that this is an extremely good idea. So when you have a Likert scale going from extremely bad to extremely good, normally there's not so many people going in the extremes, but having a quarter of respondents of early career researchers saying this is an extremely good idea is quite revealing. And you can see that then you have mid-career, then you have later career, then you have retired researchers. So we may have some trends here. I don't know how to interpret this yet, but I thought it was interesting to note this. But what does that mean to us? Well, that means that there's an overall agreement that things should change, but the specific perspectives differ between individuals, between groups, between career seniority, and etc. All right, so taking back this statement, I also want to go back to some of the findings from my focus group and interviews to show how perspectives can change. And I just want to go through two domains, which goes back a bit to the indicators. But in terms of impact factors, I really saw in my interviews that some people think that impact factors are really an indicator of quality, and that they are an indicator of how strong and how sound and how excellent the work is. And there are other people who think that impact factors are useless, toxic, and biased. The same went for open access. So most people valued open access. They said that everything should be open access. They would always try to publish in open access. But some people really had a perspective that open access was unfair, that it was biased, that because authors pay an APC to get their publication published, it means that they will accept anything and they will allow authors to publish low quality work and etc. So we really have these opposing views in different indicators of science. So there's a lot of differences in the perspective of how people see the changes that should happen on research assessment, even though we mostly agree that there is a problem. So based on that, I will just do a quick recap of what I've mentioned. So I talked about the perspectives of success in science, and I said that research success and career success are concepts that are often incompatible with one another. I also said that career success is almost exclusively focused on outputs, and it ignores most of the processes involved in research. And I said that it's very difficult to change and address these issues, and that current career structures may strengthen the problem. Then in terms of the indicators that are used in research assessment, I showed that the indicators that are seen as most important to advancing science are not always aligned with those that are seen as most important in researchers' careers, and that non-output activities are thought to be very important for assessing researchers, maybe more than metrics, but they're rarely captured in research assessments. And finally, in terms of the reform of research assessment, I said that there's an overall agreement that things should change, but specific perspectives differ between individuals. So that being said, are we doomed? Does that mean that we are in a system that cannot change, that we have a problem and nobody agrees? Or how can these perspectives inform us? I would say I'm a very positive person, so I would not say that we are doomed. And I tried to make sense of the different levels of research assessment to show a bit of the change that has been happening. Of course, just this part of the presentation could have taken an entire day because there's so much happening. So I'm just giving you a glance of little things, and I'm sure you will hear more in the presentations to come. So when we talk about research assessments, there's different levels that we can think of. And the indicators is the first level that we think of. This is how I started my project. I was interested in the perspective of the indicators. What is success? What are the indicators that you use to attribute success? And changing this is one of the first steps to changing research assessments. There has been a lot of reports and documents and declarations and manifestos about this. And I think we are really starting to move. DORA is one of the big actors, and I will not go in details into their work because you will have a treat later in the afternoon about that. But this is the first area that we need to address. But we cannot just stop at changing indicators. We have to also move further. And another point that needs to be addressed is the assessment. So how do we look at these indicators? And I thought it was very interesting. Yesterday, I attended the presentation from Francesca about equitable hiring in the ESO. And I thought a lot, also in the discussion yesterday, was reflective of these assessments, like training for assessors, diversity of assessors, who's looking at these indicators. So this is also really starting to change. So we take care of the diversity. We started having also narrative CVs, 360 evaluations, so that so that you don't only take the opinion of those who supervise you or who are above of you, but also when you assess a researcher for tenure, you ask the students what they think of the researchers, and etc. and etc. There's loads of examples of that happening. So I think this is a very positive change. If you want more examples, on the DORA website, there are case studies, there are loads of resources that have very clear examples. And I think this is all extremely optimistic for the future. Then I don't stop here, because beyond the indicators, the assessments, there's also the structures where we assess researchers. So what are these researchers living in? Do they have career security? Do they have opportunities for changing their career? Are they supported and trained to respond to new assessments, to changes in research assessment? If we tell them you have to publish your data because this is what is going to be important from tomorrow, do you train them for that? So all of these structures are also very important to consider. And there are changes. Now there's mobilization, for example, for career security. This is the one domain probably where there's the least change at the moment, because it's a very, very big problem. But I think the awareness, the raising in awareness is going to be very interesting. So the UCU strikes that are happening at the moment in the UK, the ISE wrote a paper on precarity in early career scientists, the Camille Nous, so the ghost author, for you who don't know about Camille Nous, you can just do a quick search. It's quite an interesting way of raising awareness on the problem. There's also in the Netherlands, with the Reform and Reward program, they started allowing researchers to diversify what they focus on in their careers. So diversification of what it means to be a PI, what it means to be a researcher. That's also changing how the structures of career assessment work. There are more and more organism or talks about changing careers from an academic careers to going beyond that. And also the project that I'm working on now, the SOPs for a RAI project, we're trying to, we're building guidelines for institutions so that they can change their environments, their research environments, and make them healthier for researchers to move on and to move to different careers outside of academia to address the problems of career security. So these are all things that are happening. I think it shows that we are really reaching a momentum. And beyond these, I think there's the research environment. And this is why I called my talk the research culture. Sorry, this is why I called my talk about cultures. And this is, I think this is the point where we have the least power and the most power at the same time. So the way I see it is we are all living in a community of scientists. It can be our internal community, but it can be an international network. It can be a community of young researchers who talk together, and together we have perspective of what it means to be successful, of what it means to have impact, what excellence is, what we think of rankings. Are rankings important for us? What do we think of negative results? What are our perspectives of people who leave academia, and etc. and etc. And this culture is really important to shaping research assessments. So it's shaped by research assessments, and there's research demonstrating that, but it's also shaping the research assessments. And there has been, again, more and more reports on that. There is now in the UK, for example, since the Wellcome Trust did a research, which was called, it's very small here, but I think you can see it, what researchers think about the culture they work in. And since then, they started implementing, having culture managers. I think this is what they are called, research culture managers in different research institutions, to make sure that the culture is healthy and that researchers are able to live in a culture that helps them do good science. So there's work happening here, but I also think that this is where we can change the most. So to conclude, there's hope for change, but I think that we are all part of that change. all part of that change in how we think about success, how we think about science, how we talk about science. Do we talk about papers by mentioning the journal name, or do we talk about papers by mentioning the title or the researcher? We all have a role to play in this, and I think that there's really hope for change despite all the problems. So that's it. I think I'm looking forward for a few questions, and most of all looking forward for the discussion.
Excellent, excellent talk. Thank you, Nomi, for such a clear illustration of the situation that we're in, with, I think, the evidence from the actual researchers that you that you've done, and also part of this EU study. This is quite unique, and I mean, it's becoming more and more apparent that research on research is crucial for, you know, moving the system forward and improving it. If there's any questions from the audience in terms of Zoom, feel free to throw them in the chat or raise your hand. I see we have a first hand raise as well from Wolfgang Kenzendorf. If you'd like to turn your video and microphone on and ask your question, go for it.
Hi, Nomi, wonderful talk. Really, really, really inspiring, and also really like that you ended on a high note and said, like, no, this is changeable, which I fully agree with. So one of the things that I'm going to mention, I'm going to give a talk later on peer review. One of the things that I'm going to mention is like the importance of our field to provide credibility to our benefactors, which is the general public. And so, like, you know, I think the general public is often not asking these matters, but I think they have a hand in this, specifically because they give us money or not. So I'm wondering, like, you know, when we talk about like changing the metrics of, like, you know, what it means to be a successful researcher, so we ask the researchers themselves. So I'm wondering if it might be a good idea, or if anyone has done this, to ask the general public and say, like, what do you want researchers to use as a metric for themselves?
Yeah, that's a very good question. I don't have a straight answer to it, but it's a very interesting point. And I think, well, so one of the point that I raised in the research culture, how do we perceive impact? There's been a few papers showing that, let's say, the impact factor, which is seen as a measure of impact, is absolutely not representative of societal impact. And if you ask the community how they see impact for science, I think most of it will be in the implementation of research results, in how research changes the clinic, how it changes the knowledge, the technologies. And this is really things that are not captured by current metrics. How do we capture these things is still a bit difficult. And I think this relates to the fact that we need a diversity of indicators. We really need to look at different things for different fields so that we really address them. But I think it's a very good idea to have a public forum to say, well, we want your opinion. This is your money. This is public money. What do you want from research? I think it would be very important. I know more and more they are involving representatives of the public, but it's not a very open process, but it's some people from the public that they include in these discussions of research assessments. But I would just say this is a very good idea. I'm not sure, maybe other speakers will have known of initiatives that are.
Thank you very much for this very insightful answer.
It's a good discussion point, maybe for the later discussion as well. Luca Cortese has a question in the chat. Do you want to to unmute yourself and start your video and ask it?
Sure, thanks. Hi, thank you very much. Very nice talk. I was wondering, your survey seems to have sampled also what I would call major stakeholders like funding agencies, university management, etc. So I was simply curious whether you have seen any major differences in the major outcomes when you only focus on these stakeholders.
So the survey was only targeting researchers. The interviews and focus groups were targeting different stakeholders, and I did see some differences in between the stakeholders. I think there's more of these results in my thesis. I won't go through all the details, but for example, there was really differences in what people focused on, like the publishers really thought it was important to have data that was of high, let's say that would not need to be retracted, so they wanted data of high quality, whereas the funders, the public funders, really wanted to please the public and to have data that would have societal impact. So we had differences in between the actors, but that's data from 56 stakeholders. So I couldn't really compare it and say this is representative. The survey, unfortunately, was only with researchers, so I cannot answer this question, but I think we should do another survey to ask around and to compare these ideas.
Excellent. Thank you. We have time for one more quick question. Giacomo, do you want to ask it, and then we'll move to the next speaker?
Yeah, thank you. Take a show very quickly. Noemi, I also shared a fantastic talk, really, really, very, very nice. Also opened my mind, I have to say. But I have on one point that I want to ask, maybe if you want to answer now, maybe later, many that I want to ask, but one that came to my mind. So you show us that there are some research that leaves academia and they are happy to do so. So what do you think, or if you, what they make, so what we can learn from them? What is the message that we can give to everyone?
Yeah, that's an interesting way of seeing it. So I also teach PhD students about publication ethics, and every time I start a course, I ask my students who wants to continue in academia and who wants to go in the industry, who wants to work in something completely different, public sector. There's always some people who want to do a PhD, especially in Europe, because quite often you have a decent salary. So you just continue your studies, you know you will have a better job opportunity in the future. So some people do that, but in reality, I think there has been studies that it's about 60 to 65% of PhD students, at least, that want to continue in academia. So it's a minority of them that are willing to leave. I don't have data on this, but I think it would be interesting to understand what else do they look at while doing their PhD, where else do they get information to prepare to the industry world? Because this is what we often see, is that academia doesn't prepare you for industry. When you apply for a job with an industry or with a pharmaceutical company in biomedical science, after having done a PhD, you're not prepared for all the tasks that they have. And this is something that we're really fighting for in the Subs4RI project that I'm doing, that institutions should give a broader range of skills to young students to allow them to migrate to different jobs. So maybe, and this is a completely hypothetical, but maybe those who already know that they will move to different careers, they already seek these things. They already ask people, how do I make a CV that's going to be well rated by an industry and not just an academic CV that's very typical and that nobody else understands. So maybe they have these kind of tricks that they could teach us. I'm not sure, but that would be a good.
So you think so that group is a group that already started with that assumption basically since the beginning.
Yeah.
And then so the important part would be to help those that are maybe to accompany people during the career in order to see this as an opportunity, not as a failure, basically.
Yeah, I think it would be important first to change the perspective of moving away from academia. It's not a failure, and it's not that you're having a lesser career because you're not an academic.
Indeed.
And the second thing, to change how we train our PhD students so that they have more opportunities for change.
Excellent. Thank you very much. A lot of food for discussion here, but let's move on to the next talk. So Ute Grothkopf and Jenny Novacescu will be our next speakers. Feel free to turn on your videos now. Ute is the head librarian at the ESO. She's done many things in her professional life, but she's been particularly involved with bibliometric studies and open access. And Jenny is the branch manager at the Space Telescope Science Institute Library and Institutional Archive in Baltimore, Maryland. And she has a diverse background in scientific and public library programs, and as well as collection development and technical integrations. And they'll be talking about the role of librarians in fair bibliography curation and metric analysis. The floor is yours. You have 15 minutes.
Thank you very much. Thank you, Sean, and thank you also to the organizers for having us here today. Actually, we would like to start our talk by explaining briefly our motivation to present on this topic. Of course, we are aware that bibliographies and also bibliometrics that result from them are often criticized, and this is mostly because they are seen and interpreted in this simplified way, and that then leads to a simplified research evaluation. Now, we still believe that they do have to play an important role in order to complete the whole evaluation process, and that relies predominantly on transparency, openness, and an understanding of the benefits, but also the limitations. These are key as far as we are concerned, and we really hope that at the end of this talk, you would share this view and go away also with a deeper understanding of the future promise that bibliometrics hold, in particular with regard to equitable research evaluation. So the 4 topics we would like to touch on with you today are, we give a brief background on bibliographies and bibliometrics in general. Then we would like to look at the FAIR principles with a special focus on what they mean in astronomy, astrophysics, and also the role librarians play here. Then we'll look at the telescope and staff bibliographies as maintained at ESO and STSCI. And we want to conclude with a little view on open access and the changes this may bring. So when we talk about mission bibliographies, we here include both telescope and staff bibliographies. And as a very general definition, these are databases of publications that fulfill specific selection criteria. Now, from one observatory or one institution to another, these selection criteria can vary, and that's all fine and good, as long as it is clearly described and defined what is included in which bibliography. Typically, these databases are maintained by librarians with the intention, of course, to establish a complete collection of data and metadata, the descriptive data, which are then used for bibliometric studies. And there's a shared understanding, I'm sure you're all aware of that, in bibliometrics, namely the 2 concepts, productivity and impact. So when we talk about productivity, we typically look at the number of papers. Of course, this is a strictly quantitative measure. It's not equitable, so it's clearly favoring larger facilities over the smaller ones. For impact, we turn to the citations, sometimes average cites, indices, and various other measures that come across. This at least strives to be a bit more equitable, but Jenny will tell you more about that in her part of the talk. There are certain things that we need to keep in mind when we deal with bibliometrics, and these are that we always have to use the appropriate metric. We need to understand them well in order to interpret them correctly. And as it has been said before, in I would say 99% of the cases today, we need article level metrics, not journal level metrics, and certainly not the journal impact factor that has been and continues to be very badly used in science evaluation. Bibliometrics are also best used intra-organizationally. As soon as you go outside and try to compare and benchmark with others, it usually gets very messy and problematic. And finally, we should really aim for responsible and comprehensive metrics, taking into account all kinds of research artifacts, and in particular moving towards rewarding open science activities. Now, what does that mean? How can the scientific community move towards open science and make sure that their research artifacts, their research output is actually valuable to other researchers? Well, fortunately, there is a nice toolkit that has been published, so to say, in 2016. And these are the so-called FAIR guiding principles. FAIR stands for make your research findable, accessible, interoperable, and reproducible. And in this slide here, we are trying to show you a few examples of what is already there with a special focus on astronomy. I don't want to go through the whole list, but we invite you to look at the slide later if you feel so. I just would like to highlight a few of these guidelines to put them into context and fill them with a bit more life. So for instance, the findable guideline number F1 says use unique and persistent identifiers. Now, fortunately, the digital object identifiers, or DOIs, have already been invented and are widely used by publishers to identify the papers that they are publishing. And increasingly, they are also used by observatories, certainly STSCI and ESO, for data sets. And in a similar spirit, we also have the ORCID, the Open Researcher and Contributor ID, that is very suitable for researchers, and Jenny and I always promote that to our researchers. Then if we skip forward to the interoperable section and look at one of the statements there, one of the suggestions, it says to use formal shared language for knowledge representation. Now that sounds pretty abstract, but if you look at it, especially in astronomy, things like the FITS file format has been around for the longest time. So this suggestion is all about using agreed standards that are shared across the community. The IVOA standards are another example that has been applied widely in astronomy. And for keywords that are being tagged to scientific articles in order to describe the content, more and more journals are actually using the standard Unified Astronomy Thesaurus, or UAT. So also here we see a certain homogenization. Now, of course, science does not stand still, and new things are evolving. Scholarly communication is going on, publishing sees new trends and standards. And in that role, actually, we librarians try to widen our view and extend our roles, and try really to put the FAIR principles into practice. And just to give you a few examples here, for instance, we act as collaborators. This is certainly shown by the fact that Jenny and I are presenting together here today, but also, especially in astronomy, we have a very nice collaboration among other astronomy librarians to exchange best practices and agree on policies and standards with special regard to our telescope bibliographies. Then we are also mediators and communicators. We talk to our scientists, but we also talk to publishers, to providers of research content like ADS and Archive, to vendors. And we tell each other about latest developments and bring forward also feedback to the respective groups. And when we do so, we actually often are also advocates because, for instance, when it is about changes that are brought on by, let's say, funders like the Plan S or other research funders, we try to interact with them and make sure that the specific needs of our community are met in these new standards that are being suggested by these research organizations or funders, because we know exactly that if the requirements of our researchers are not met, the new guidelines will not be applied, they will not be accepted, and there will not be no buy-in, so to say, from the community. And then finally, we are also builders and initiators, so to say, and in this regard, we provide science support. Sometimes we initiate projects across our organizations if we see that newly evolving standards are actually applicable not only to libraries, but across our organizations. And with that, we want to move to the next part of our presentation. Now we want to focus a bit on our bibliographies at STSCI and ESO. First, we talk about telescope bibliographies, and just to remember or remind you of the purpose of these telescope bibliographies. Of course, their main purpose is to interconnect resources and to make it easy for readers, for instance, to find the underlying data. As we have indicated here, this is very easily also achievable in ADS result lists, where you just click on the little data stack and you are linked with the archives that provide the data, or the telescope bibliography databases. Information coming from our databases then can be used to study, for instance, observing program characteristics vis-a-vis the respective output. In general, they inform the researchers and our institutions of how data is used or reused, and sometimes repurposed, if you think of archival data. And of course, in general and extrapolating from there, you can also assume that they provide suggestions for future instrumentation, as well as for possible decommissioning of facilities. And with this, I would like to invite Jenny to take over and guide you through some examples that we have prepared.
All right, thank you, Uta, for getting us oriented to some of the work we do. So to give you a more concrete idea, just touching still on the telescope bibliographies, later we're going to talk about staff bibliographies in a moment. Some ways that these metrics have been used. We certainly have telescope bibliography. The main question often is overall productivity. So we know that our management and then our funders will often ask for this question. And again, this is a really simplistic view of productivity, but total number of data publications is what we're showing here for ESO. In that, it's broken down. I know it's hard to see in here, but in the Zenodo view, you'll be able to dig in a little bit more. You can see the lighter purple line is the number of papers that used archival data and how that has grown throughout the years. And this is just one example of why this curation or metadata collection has been so important to our institutions. When we started and built these telescopes, this wasn't a question that I think we even thought to ask, but having collected it, we can now see how archival data is actually growing in usage, often beyond kind of newer PI or GEO data. Uta, if we go to the next example. This is another ESO telescope bibliography view. And here they're tracking the use of basically data papers that used data and observations coming off of some of the main instruments on the VLT, the flagship observatory for ESO. So just two examples Uta highlighted. MUSE, you can see how quickly usage went up just in a few short years. And then UVIS is still pretty much a workhorse for VLT, very much consistent data output and data paper usage here. Uta, if we go to the next example, and again, these are just brief views. We're going very quickly just to give you an idea. These come from Space Telescope, Science Institute's bibliography for the Hubble Space Telescope. And if you look, you'll see the strange flip in the orange. So the orange here is tracking archival data usage in a publication. And you can see, and it's hard to see again on the graph, but in 2003, essentially what happened was there were more papers using our open archival data than what you would think of as new data or PI data. And actually the green below shows partial archival and guest observer usage. So again, just another thing that we're able to say by tracking and curating the data that we gather. And the importance of it is part of kind of touching back. We'll get to that in the staff bibliography part. So again, this is touching on telescopes, not people. Here in the example 4, I'm going to ask Uta in a moment, not yet, to flip to the next slide, but this shows just a few years of operation, about 4 kind of active years of Hubble. You can see that papers, this is measuring essentially the first authors of papers using Hubble data. Really, it only was being picked up and used in North America, a little bit of mostly Western Europe, India, Japan. Uta, if you go to the next slide. Here we are 30 years, into Hubble telescope data collection. And we can see that authors around the world, thanks to the work that our Mikulski Archive for Space Telescopes do to make the data accessible, is now being used essentially in most, at least most continents. We even have Antarctica, can't see it down there, as well as South America, Central America, Russia, China. Again, the expansion of data use has really grown in 30 years. And without curating this, it wouldn't be possible to show that expansion. And again, touching back to the FAIR principles, this gets to the fact that the archival data is open and available for reuse, both for ESO and STSCI. We're going to switch gears entirely. And I think this part will connect more to Noemi's talk from this morning. So staff bibliographies is something that we also track. And I just want to give an example, talk a little bit about how we use metrics as just a very small piece in the evaluative process. And then how do we think about using the full scope of science activities? So for us, a staff bibliography doesn't just mean metrics, it means capturing the breadth of science activities. You can see mentoring, teaching, we count instrumentation, software, data notebooks, basically anything that's an output and also non-output can be measured in the evaluative process. We do quite a bit to ensure fair comparison for career stage, gender, and research areas. Just to wrap up this portion, how we focus on equity is picking one standard, in our case, ADS. We don't compare, we don't mix and match with Google Scholar and Scopus. We do make sure we use those consistent name and entity associations for ORCID and RORs. And that's to make sure we don't discount something that belongs to the researcher. H-index, I think there'll be a lot of discussion later, is such a small piece. If it's used, it's accompanied by the M-index, which divides it by years since the first paper, since PhD, depending on how you want to do that. And I know that Stephen Curry will touch on this with Dora. We do maintain legacy staff data, and that's really important for benchmarking against someone at a similar point in their career. So I can talk more about that offline if anyone would like to know more about that. And finally, two really important things. We've removed self-citations. There's quite a bit of research to show that women don't often self-cite as much as men. And so that measure could be detrimental if used for all researchers. And we enable degrees of first authorship. So essentially, if a generous, experienced researcher is going to give the opportunity of first authorship to one of their students or a postdoc, they still have a way to claim that as being, for all intents and purposes, first author. So again, it's trying to make some of these measures more fair based on what researchers should be doing, but not what they're simply being measured against. And then our last piece, I know we're ending on time, so this is really our last substantial slide, open access. There's been so much talk already, again, in Noemi's talk, on what role open access will have in all of these shifts in how we measure productivity or researchers' output. Open access is a part of the shift. It does mean the shift, as you all know, from subscription-based journals to something where the content is more publicly available, with the intent that publicly funded research can be read anywhere by anyone. The fact that astronomy is now shifting to open access, particularly for the American Astronomical Society journals and Astronomy and Astrophysics, ANA, does lead us to three main effects that we'd like to track over time. So effect one, anyone around the world can now read that content, they can cite it. It could mean future impacts that you'll see in effect three. Effect two really is something we're concerned about, insecurities and questions. So who will pay? Are there going to be higher publishing costs and APC charges? Will there be funds available if the funding essentially shifts from the library or the subscription to the author? These are all questions to be seen. And it's a new model in astronomy. It really just happened this year for the major journals. The third effect is the one that we're most interested in tracking. Will authors who publish in open access be cited more because simply their research is more accessible? Will it impact what their measurements look like stacked up against a researcher who hasn't published as much open access? So these are all things that we'll need to track over time, especially when we look back at the full staff evaluative process. So in conclusion, I'll leave this here today. Again, I want to respect the time that we have, but we have, just a summary of our message from today. I'd really look forward to the Q&A. I think especially our staff bibliography portion touches on Noemi's talk a lot this morning. So if you have questions, you may contact us here. And again, we welcome your questions during the Q&A portion or after. Thanks.
Excellent. Thank you very much, Jenny and Uta. That was a quite broad but quite informative discussion on metrics and the importance of data. And I think that you raised a lot of really interesting points that I actually never even thought about, the usefulness and the necessity of librarians. We have two hands up. We'll start with Thiago Gonçalves. Please unmute your microphone and turn on your video and feel free to ask your question. Okay, you can't unmute yourself. Up there you are.
There you go. Thank you. So great talk. Thank you, and to the previous speakers as well. One thing that I was wondering about, and I think Stephen Curry also brought it up, and this is something I was discussing with someone else, and we discussed it a lot yesterday in terms of diversity, especially, is the idea of using a wide array of criteria to evaluate people, and that goes into outreach activities and whatnot. And I fully support that. I think it's a great idea. My question is, how does that work in practice? Because Stephen has brought up the point here of survivor bias, and this is something that we have also addressed yesterday, because these are the people that have gone through the system as it is. And at least in my experience, I feel that those evaluators are the ones that are mostly valuing the old style evaluation of H-index and number of articles and whatnot. So how do we actually promote change in that way? Because I think it's important. I really don't know how to do it.
I can touch on this a little bit. Actually, I think our head of our science mission office may be online as well, and she's a part of this process. So in our case, the evaluative process, it has been on hold during COVID, but the body that evaluates their peers changes with every cycle. So it's never the same group looking at the same kind of comparative evaluative pieces, right? Like how much outreach did you do? How much did you publish? What kind of data and software papers have you put out? Have you done talks? Have you presented both to the public and to your peers? So I think that's one piece, is making sure that there is a true rotation and an opportunity for both junior and senior researchers to be part of that evaluation group. Having a mix of evaluators and their experiences is one simple piece of it.
Did you want to respond as well? Or?
Yeah, I would say at ESO, we are in terms of these inclusive metrics, perhaps not as detailed yet as the STSCI, but I think the very first step is, of course, awareness, and that is very clear that this awareness is available, and we are putting pieces together, let's say, to find more complete pictures for research evaluation. And I think what is essential here is, like what we also try to say in the presentation, it's collaboration, not only coming from one department of one area. It really has to be settled deeply and rooted deeply in the organization at large. And this is, I think, what goes back also a bit to Francesca's talk yesterday, where she made it very clear that ESO is very bound to that and trying to make big steps forward.
Excellent. Thank you. In the interest of time, let's move on to the next talk. The speakers will all be around for the discussion after the break, so please stick around for that and ask your questions there. Thank you, Ute. Thank you, Jenny. We'll move to the next talk, which is from Wolfgang Ketzendorf. Wolfgang is an assistant professor in astrophysics and computational mathematics, science and engineering at Michigan State University in the US, with research interests in supernova data, big data astrophysics, and natural language processing. And his talk will be around peer review in a global and growing scientific community. So Wolfgang, you have 15 minutes. The floor is yours.
Thank you very much. Thanks so much for the speakers before me. I mean, you've given amazing intro to some of the stuff that I will be talking about. And it was really riveting to sort of hear about these things that we normally don't talk about, even though they're fundamental to the things we do. Let me just make sure everyone can see my screen, and I'm doing well as well. So I'm really riveted that you're putting this conference together, and I found the discussions, particularly on Monday, very, very stimulating. And I'm hoping for similarly stimulating discussions today. So as Sean said, like, my name is Wolfgang, I'm professor of data science and astrophysics at the Michigan State University. And in this talk, I want to give an overview of peer review and the world that it is confronted with. I will give a very brief overview over the many troubles of peer review, and then specifically also in light of the panel discussion afterwards. And I also will try to sort of highlight some of the solutions, potential solutions, before I conclude with sort of the current status of peer review. So I want to start with, like, doing this as a two-parter and talking about, first of all, peer review, and then, like, how the world has changed. And I think, like, the most important thing is, like, we rarely think about, like, what is peer review. And I mean, obviously, like, the typical thing is the Oxford English Dictionary defines peer review as, but I mean, this is no longer true. And we have Wikipedia now, and I think, like, in 2022, this is the right thing to say. So peer review is the evaluation of scholarly work, research, or ideas by one or more people with similar competencies as the producers. This is very similar to what is written on Wikipedia. I've changed a few words around.
And
But
Wolfgang,
essentially,
sorry to jump in. This is Giacomo. Sorry, Sean, because I was watching the streaming on YouTube. There is your slides are cut, Wolfgang. So can you maybe put in on full screen? Maybe see, yes. Yes. Now it's coming. Yeah.
okay.
Because otherwise, it's a pity because a part of it is not visible. Oh, now I think is. Thank you. Sorry. Perfect. Thank you, Sean. Sorry.
Sorry about this. Sorry to
No. So very good.
upset the technology. Does this still work?
Looks great, thanks.
Okay, so essentially, peer review is a form of self-regulation, and it's quite unusual in society that a publicly funded organization or publicly funded sort of area sort of self-regulates. Most of the publicly funded areas, like the government, are not self-regulated. They're regulated, like in a democracy, they're regulated by the people, and so it's quite unusual that we have this luxury of self-regulating. And so peer review is one of the ways we do this. And it should, according to Wikipedia, be used to maintain quality standards, improve performance, and most importantly, provide credibility, not only to us, but also to the public at large, that funds us and that uses our research, I mean, specifically medical research, to sort of move forward. So I'm going to talk about today about two distinct purposes for peer review. One of them is like quality standards for papers, and the other one is research allocation. I will focus much more on the latter than the former, but I think both of them should be kept in mind. And I think in the examples I will give, I will sort of mention when the former is being applied. So just to talk about some history about peer review. So credibility of science is most crucial in medical sciences. No one wants to give their kid to some quack that just cuts them open and kills them. So for medical science, and this is where peer review sort of first started, it is crucial that we have trust of our trade from the public. And so Ali al-Ruhawi in 900 CE wrote in Ethics of the Physician a framework where as soon as you start treating someone, you wrote 2 journals. And one of the journals, after the successful, unsuccessful treatment, you gave to the other physicians. And they were studying it and they were judging you. And they were saying either you've done it right or you've done it wrong with punishment. And that provided credibility for the population that people don't just do nonsensical things. So jumping ahead roughly 800 years, the Royal Society of Edinburgh started to use more modern peer review in the editorial process. Normally, the editors normally the editors were allowed to sort of say, this is what we publish or this is not what we publish. But in 1731, people started to say, we're going to give this to scientists to judge if this is worthy to be published in ours. The final decision, as it is now, still rests with the editor. And so peer review is very young. The modern peer review, it started in the second half of the 20th centuries and became more widespread, specifically because a technology called the photocopier became available. So we could make copies of manuscript and sort of send them around. So I talked about peer review. I'm going to now talk about the growing and global scientific community, and I'm really going to focus on the growing because I think that is super interesting to see when I plotted the numbers, and I think I really want to share this. So on the y-axis, we have human population in billions, and on the x-axis, we have year. And we can see we have been extremely prolific in the last 100 years. We've increased our numbers by a factor of 8, which is crazy. And so when these first ideas about peer review came about, we were 500 million people. And so the first modern peer review, we were still under 1 billion people. And so when the current modern standard of peer review became more widespread and a lot of the foundations are still the same, we were a quarter of the people than we are now. So just to go into a different things it's not only the number of the number of humans, but it's the number of nerds that we're talking about here, the number of scientists. And so one of the things we can sort of look at, number of billion people on the left-hand side, and on the y-axis again year, and we can see the world population on the top, and the number of world nerds, researchers as classified by the UN, is on the bottom. And you can see there's a steady increase, 1 per mil, so 1 in 1,000 people are researchers. And this is growing. So this is net births, and I'm going to use a nerdy unit called, using the nerdy unit called Hertz. So how many net births, like, this is births minus deaths per second. And so we can see, like, while the human population in this is flattening out, like the number of researchers is growing because we've become increasingly good at like keeping people alive through farming techniques and other things. So a lot of us can think and have time to think about things. And so if we take this obviously to the logical extreme, like, in the year 2020, 30, like, the nerds are going to take over, and we will have parity, and there will be equal number of nerds and humans being produced per second. So all jokes aside, I think like one of the things that we really need to think about is that peer review was established at a time when we were much fewer humans and even fractionally much fewer researchers. And so this is just one of the troubles of peer review that, like, will come up. But I think this is a really nice background for many of the discussions that I'm hoping we'll have. So one of the things about peer review, specifically in the natural sciences, and we talked about this on Monday, is finding objective truth, right? I mean, that's what at least the natural scientists are all after. And so we obviously also want a process that is a foundation of our trade to be able to find objective truth. And so one of the metrics, so how do you measure this? One of the metrics could be, if I give you a paper and I'm going to ask you to grade it and say, like, this is great or this bad, and then I give someone completely different a paper, you would hope that these things match. This thing is called inter-reviewer reliability. But we've known since 1981, this does not match. So essentially, like, if you give a work of science to one person and then ask another person, in 20 to 40% of the cases, they agree. So it's very, very low. So in astronomy, like, we've done this experiment. So Nando Patat in 2018 and myself and Nando Patat and others in 2020, we've sort of looked at this. And I just want to briefly sort of like give an overview of, like, this thing. So on the x-axis, we have the panel 1. On the y-axis, we have panel 2. And so 1 means worst quartile, 4 means best quartile. Given a work of research, in this case, it was an ESO proposal, if the first panel judges the work to be, if the first panel judges the work, I think the numbers are switched around. No, that's correct, sorry. If the first panel judges the work to be in the best quartile, then there's only a 41% chance that the other panel also judges it in the best quartile. So the first panel says, this is the best thing we've ever seen. And then we ask a second panel independently, do you agree? And only in 41% of the chances they agree. If it was completely random, it would be 25%. So if the first panel says, like, this is the best work we've ever seen, or in the top 25%, the second panel has a 10% chance to say, like, no. This is one of the worst things we've ever seen. So this inter-reviewer reliability is not very large. There's people that argue maybe that's a good thing because that means you have a varied point of view. Other people argue that means it's random. So it's unclear, and I really want to stress this, is like we can't immediately jump to conclusions to sort of say this means it's bad. But I think we really have to, there's a large amount of literature I think we need to, like, digest and go through. The other one is, like, one of the problems of peer review is bias in peer review. There's long-standing bias issue also present in peer review. Like, we've talked about bias in the research field, but in peer review is one of the foundations has this. Like, one of them is like institutional bias. CC and Peters essentially went in and they said, okay, if I take Harvard off the paper and put, like, community college in East Lansing, let's say, it has a significantly lower chance of being published, even though it's the same paper. Gender bias in peer review has been discussed for a long time. Veneres and Wald have in 95, and I'm sure people beforehand, these were just some of the papers that I found interesting. And so on the right-hand side, I'm going to show a graphic where it says the quantifiable publication metrics, H-index, so to speak, on the x-axis. On the y-axis is like the subjective competency score. And you can see, like, for the same quantifiable quantitative publication metrics, women are judged less competent. And this is in a study of Winner's and Wald. And there's also bias of negative outcome. This is more in the medical field, but it's also see what like Naomi was saying. Like essentially, it means like if you don't find an outcome, if you don't find cause and effect, it's much less likely that you're publishing it, potentially leading other people to do the same experiment and wasting time. We also overwhelming the system, like review works of science need peer review. And so we need reviewers for this. And it's only a fifth of researchers and mostly senior researchers that perform this task. Mostly senior researchers, the fifth of researcher, perform essentially 70 to 94% of reviews. This was published in Covanes 2016. And so that means people, as we're becoming more and more people producing more and more work, there's more and more reviewer fatigue. So I think in 2003, the number of declined reviews was only 30%. This rose to 50% over 10 years. So where is this going? Are we not going to have any reviews in the future? And in addition, this is part of our own from our own collaboration Deep Thought initiative. We can sort of see the submissions to AstroPH are doubling every 14 years. The number of researchers is rising, and the numbers of work that are being produced is rising. Cost of peer review. The rising number of researchers and rising number of research products means we need to do more peer review. And the constant funding for fundamental science has been seen in several countries means the chances of getting successful peer reviews specifically for grant proposals are getting lower. And so there's a really interesting study by ASTRO2022, which has sort of said if you spend a large amount of time writing the proposal and then reviewing the proposals, but your funding rate success chance are really low, how much money is society really adding into the system? And so one of the things they said, if, for example, you have a 10% funding success rate for a grant size of $100,000, essentially society is not adding something to science. All of this is being sucked up by people writing grants and people reviewing grants and administering the system. So some solutions, and these are only some solutions, and I really am a positive person, and I think these things are doable, and I'll be done in a second, is the dual anonymous peer review. It is known under the term double blind, but to be inclusive to the disabled community, in astronomy, we chose dual anonymous peer review, but it's the same as double blind. It's used in social sciences and humanities for many procedures, and alleviates biases during the peer review, and there's many research on this. And I'm going to quickly say that NASA and space telescopes are using this. And so for cycle 24 and cycle 27, where we have dual anonymous versus non-dual anonymous, the number of junior PIs success rate went up. It's very interesting, the number of female senior PIs went way down. And this is unclear, and I've started to ask and sort of see is this actually a trend? But I was assured that they are tracking this, and for now it doesn't seem to be statistically significant. So the other thing that we've done specifically at ESO is the distributed peer review. It was suggested by Merrifield and Sari in 2000. It was suggested by Merrifield and Sari in 2009 for astronomy. It existed before, which means essentially what we're doing is we're asking the people that are proposing also to review. It has been in action in the Gemini Fast Turnaround Program since 2015. There's a paper by us in 2019. We've done the ESO distributed peer review experiment in 2018, which was published in 2020. And so essentially we used the distributed peer review. We used some machine learning matching algorithm for review and proposal. And we enhanced it with the review on reviews, and we can talk about this later. So this is a quick graph, and I'm not going to go over this, and we can talk about this in the discussion. I'm happy to show that slide again. So conclusions. Peer review is a deeply flawed system. It's a horrible, deeply flawed system, similar to democracy. But I think it's the best we have, and likely better than alternatives, specifically as we need to be credible to the public at large. Difficulty to ensure maintaining of quality standards, increased performance, and, as I said, credibility to our benefactors. It is the foundation of our trade and the trust that is placed in us. And it's a complex endeavor deserving of the same care and research than our astrophysics endeavor, specifically from people within the sciences. So where are we going? There's no perfect peer review system, just different trade-offs, and we need to be clear about this. Dual anonymous becoming the norm, like we're closing the seniority gap. It might be potentially problematic for open science projects, where people like, put work into open science project and someone else writes a grant and says, I'm going to use this software. And the people that wrote the software are not getting the grant, but the other person that can just use the work. Distributed peer review lessens the burden, brings more voice to the table, distributes the load, but might hide the problematic increase in costly peer review. So many more innovations that can improve the system. Interdisciplinary, I think, is a must. We should talk to the other sciences. What do they do? What works for them? And we can change, similar to Noemi, I really want to stress, we can change the system for the better. And on that note, I'm going to say thank you very much. Thank you very much for organizing this and for listening to this. And I'm really interested in the questions that you might have.
Thank you, Wolfgang, very much for that quite interesting and unique talk. I think I learned a lot about peer review and history, as well as where we're going. In the interest of time, so that we can have a little bit of a break, I'm going to ask those to hold the questions for the discussion, and we'll jump right into the next talk. So Martin Dominic is our next speaker. He is a reader at the School of Physics and Astronomy at the University of St. Andrews. His research focuses on applications of gravitational microlensing effects, and in particular, its potential for studying planets orbiting stars other than the sun. And he'll talk today about research assessment, so not, and the recognizing the asset of this diversity and for scholarship serving society. So if you want to share your slides, you have 15 minutes. The floor is yours.
Okay, hello everybody. Now, evaluation has become omnipresent. You cannot travel anymore without being asked to rate your flight, taxi driver, hotel, or restaurant. And once back home, your opinion about a cashier in your local supermarket is requested. It should therefore not surprise that the rise of scientometrics over the last 15 years follows this fashion trend. Notably, these are not rooted in tradition. The age index specifically was only invented in 2005. Fashions come and they go. More recently, push for quantifying so-called impact means that there's now hardly any public engagement with science without feedback form. This obsession with metrics comes along with a striking absence of sensible judgment in management. As Jerry Muller in his book, The Tyranny of Metrics, stresses, measurement is not an alternative to judgment. Measurement rather demands judgment. Judgment about whether to measure, what to measure, how to evaluate the significance of what's been measured, whether rewards and penalties will be attached to the results, and to whom to make the measurements available. Simply delegating decisions to numbers means dodging responsibility. Metrics have become a much profitable business, exploiting the prevalent lack of judgment. Large publishers have turned into IT giants, claiming to provide information-based analytics and decision tools. But those tools have turned into instruments of power. Once you control publishing, and you control assessment metrics, and you can claim proprietary rights to the underlying data, you not only take ownership of the research process, but by shaping your gigantic scientific industrial complex, you also redefine societal values. We need to break free from that. Productivity is a much ill-suited concept when trying to assess the research ecosystem. Paul Smaldino and Richard McElrath argued that incentives for publication quantity can drive the evolution of poor methodological practices through what they called the natural selection of bad science. The worse your methods, the more false positives are claimed as exciting discoveries. The more of those you produce, the more funds, the more students. And the worse the science, the higher the replication rate. How do we break that replication cycle? Citation counts and derived metrics tell us what is popular. They're not objective, but result from subjective decisions, providing us with a map of social networks. That is, social processes do not create a bias to citation counts, but these are what citations are measuring in the first place. Judging by network completely contravenes recognizing those who are marginalized. The brightest kid in school did not tend to be the most popular. And the scientific mainstream is at least a decade behind the forefront of innovation. Those who are much ahead do not have many followers because they think unlike the majority. So, how do we move forward towards building an efficient research ecosystem that advances knowledge for the benefit of society? We need a trustworthy public record of science, part of shared human culture. Advances need to be communicated so that others are able to build on these, eventually leading to translation into societal benefits. There's no dichotomy between fundamental and applied research. That's the wrong fight to take. All research that significantly adds to the scholarly record holds the potential of being translated into concrete value for society, be it sooner or be it later. Not necessarily by those who originally carried out that research. Many approaches to research assessment are based on the fundamental misconception of the universality of research excellence. Best for what? Meaningful assessment needs to serve a specific purpose. And there's no meaningful universal ranking, neither at global, national, regional, or institutional level. Depending on specific context, research assessment is to take various forms and is to use various criteria. Assessment metrics tell us that the answer is 42, but we've forgotten what the question is. Biodiversity is a key feature of biological evolution. And similarly, the research ecosystem is and should be diverse at various levels of granularity. In fact, diversifying to occupy every niche in an ecosystem provides a much larger value than engaging in a competition that has one winner only. And diversity provides resilience. Actors within the system do not operate in isolation, but interact within a specific context. This holds at every scale and level, from research group to global society. Diversity again emerges as one of our greatest strengths, making our society thrive and letting us work together. It is not a competing goal to excellence, right to the contrary. The quality of teams hinges on the complementarity of skills and on the interaction between its members. Those who are quite similar and interchangeable don't make a good team. Relevant assessment criteria do not trickle down from larger units to smaller ones. You don't form a good football team from those players who scored the largest number of goals. People successfully use their skills in various roles, and practices that are relevant in one role might not be relevant in another. However, the freedom of diversity of practices should belong to each individual researcher, not to so-called disciplines. We need an overarching framework that appreciates diversity of individuals and does not look them up in disciplines. Expecting specific track records is a key obstacle to mobility and diversity of career paths. neglects specific circumstances, and ultimately is a great disservice both to those assessed and to society. In particular, there are substantial differences between academic and industrial environments, governmental and not-for-profit institutions. If something wasn't relevant in a previous role, there's no track record of it. Measures of productivity again fail on the diversity of environments, conditions, and circumstances. While the central point of the San Francisco Declaration on Research Assessment, DORA, is not to judge publications by where they have appeared, we also might want to consider not judging researchers by where they have appeared. We need to distill and value the intrinsic traits, skills, and competencies. If we look at research and its benefits, we should carefully distinguish between processes, outputs, and outcomes. Specifically, outputs is what you produce, outcomes is the difference it makes. While it has been most popular to judge the research process by its outputs, more recently the focus has shifted to also consider judging the research process by its outcomes. But I would argue that we should rather judge outputs and outcomes by the process, valuing the journey rather than the destination reached. We should be looking for those who are good at practice, not those who happen to be lucky. Rewarding luck is not any better than choosing at random. In fact, the Hong Kong principles developed during the 6th World Conference of Research Integrity in 2019 place the scientific process and good scholarly citizenship at their core, emerging from the fact that knowledge must be trustworthy to benefit research and society, and trustworthy research is robust, rigorous, and transparent at all stages of design, execution, and reporting. We're discussing peer review in the context of scholarly publishing, but it actually is a form of research assessment. How should we develop it and make good use of it? A specific quality of the scientific process is its efficiency and the economical usage of resources. Some prevalent assessment metrics, right to the contrary, celebrate wasting money. I would be quite interested to see US Ivy League universities compared to Central African universities on this point. In the policy sphere, I keep hearing about how to incentivize, but we should talk more about supporting initiative and building on human creativity. I think that the better strategies are built with people rather than for them. You definitely do not foster leadership by already predetermining the direction of the journey. With creative freedom comes responsibility. And our societal development requires empowered and responsible actors, able to decide for themselves what is right or wrong. Ethical behavior stems from responsibility, not from rulebooks. If assessment, however, operates within fixed expectations, there's no room for acknowledging outstanding contributions. This requires flexible goalposts. High-risk research strategies have their place in a well-mixed portfolio and would be disingenuous to blame individuals for their failure. So to summarize, purposeful research assessment can be built on 5 major pillars: specificity and purpose, diversity of practice and team roles, intrinsic traits and diversity of career paths, qualities of research processes, as well as creativity and initiative. Diversity is our key asset, and actors need the freedom to be different. There's outer pressure, however. Notably, signing up to the idea that university rankings confer valuable prestige, institutions enter a competition in which almost everyone will be a loser. Outsourcing values to such rankings stands in the way of meaningful development that lets institutions flourish in their specific niche that sits within the diverse system. Some of these rankings might be interesting, but attaching undue relevance to them is fatal. They must not serve as excuse for bad management. Critical judgment is required. Finally, I would like to acknowledge many discussions I had with others on this topic over more than a decade, in particular those within the Global Young Academy working groups on scientific excellence and on open science. And a few years ago, we published a report, Publishing Models, Assessment in Open Science, discussing the connection between these issues and how to develop structures that will make research flourish as a truly global endeavor. If you want to see changes happening, be assured that you are not alone. But that change needs you. Don't hesitate to call out nonsense for what it is and join the efforts. You will make the difference. Thank you.
Excellent. Thank you very much, Martin, for that inspiring talk with a wonderful set of ideas that could help, I think, move us towards this culture change that Naomi was talking about at the beginning in a nice and positive way. Maybe we have time for one quick question. If anybody would like to ask one, raise your hand or throw it in the chat. If not, then we can save all of our questions for the discussion coming afterwards. I'd like to thank Martin and all of our speakers that have been here before the break. We will now take around 20 minutes of a break and come back around 4 o'clock, 16 o'clock Central European time for Stephen Curry and the discussion round afterwards. So thank you all. Have a nice break and we will see you soon.